Hi there, we're looking at adding fractions, proper fractions, adding and subtracting them. Okay, so I've got some success criteria here. I know what a fraction is visually. I know how many fraction parts make a whole. I can add fractions with common denominators. I can find equivalent fractions. I can see the issue with fractions with different denominators. I can use equivalent fractions to get a common denominator, and I can see the link between equivalent fractions and common factors, and I can make the link between equivalent fractions and prime factors. Right, let's see if we can get there. And I'm going to use the use of a really cool app, interactive fraction wall. So here's a fraction wall, and if I have a look at that, if I make it more coloured, you can see that here I've got one whole, and here I've got two halves. I've got 3/3, and 3/3 is equal to a whole. And you can see straight away that fractions are parts of a whole. And you can see that if I want to know how many fractions make up a whole, if I've got quarters, I need 1, 2, 3, 4. And for tenths, okay, if I got 10 tenths and I take away 1, I've got 9, 8, 7, 6. Okay, so the number on the bottom is the denominator, and that tells you what size fraction they are. So these are tenths, okay, so it's the type of fraction it is. Whereas the number on the top, so you've got 6 tenths, that tells you how many of those that we have. So we know what a fraction is visually in a strip here like this. So let's just check my success criteria. I know what it is visually. I know how many make up a whole. Okay, fraction with common denominators. Let's have a look at that. So let's clear this. So if I had, say, 3/6 plus 2/6, you can see all up I've got 5/6. Okay, and so that's pretty straightforward, and it's pretty easy to see when you see it as a picture. All right, let's have a look where we're going. Let's tick that off. Now I can find equivalent fractions. Okay, so let's have a look. If I had 2/4, I think that's quarters. Oh no, they're fifths. 2/4, you can see that that is the same as a half. Yep, and if I want to see all the equivalent fractions, let's do that, and you can see that the half is 2/4, it's 3/6, it's 4/8, and 5/10, and you can see that those numbers, 6/12. Let's do another one. Let's do, what's this, a quarter? Okay, a quarter there. Here's a third, it's 2/6, 3/9, 4/12. Okay, so these are equivalent fractions. And if I was using, if I was just looking at it in terms of numbers, 2/4, I'm going to make the link to equivalent to factors. And so 2/4, well, 2 is the same as 2 times 1, and 4 is the same as 2 times 2. And you can see that I've got the same number on the top and the bottom, so they can cancel out, and I get left with 1 on 2. And 9 is the same as 3 times 3, and 15 is the same as 3 times 5. Okay, and I've got a common factor on the top and the bottom, so they can actually cancel out, boink, boink, like that, and then I'm left with, I've got 3 on 5. Let's have a look at another one. 21 is the same as 3 times 7, and this one is 4 times 7, so I cancel those out, boink, boink, I end up being left with 3 on 4. Okay, in the same way, we can make 3/4 equal to other things by multiplying the top and the bottom by something. So let's do 5. So 3 times 5 is 15, and 4 times 5 is 20, and there's an equivalent fraction. So if I look at, let's go back here, what did I have? 3/4 and 5/20. So let's clear that out. 3/4. Oh, I don't have my. Well, I got. I might have to do it like this. Just a minute. I might have to. Oh, I don't have it. But for thirds, here's all the equivalent fractions for thirds: 6th, 9th, 12th. If I change it for fives, you can see I've got 5ths, 10ths, 15ths, because 5 2 times 5 is 10, 3 times 5 is 15, 4 times 5 is 20, and this is, oh, I don't even know, let's show that. Whoop, that's 1. What are those question marks about? Oh well. Anyway, so you can see there how equivalent fractions work. So they are really important for when I'm trying to add fractions that don't have the same denominator. So for example, if I did a half and a third, so I go half, oops, let's not do equivalent fractions anymore. Let's clear that. So if I had a half and a third, I'm going to add those. The problem is that I've got different size things, so when I put them together, it's an issue. So if I look at this, my lowest common multiple, here we go. So halves and thirds, to make them, so what if I can find a number that both of these will divide into, and here we go, 6. So half of a third is a sixth, so I've got 2 sixes equal to 1/3, and so I can put 6 in there as well. So and 3 sixes equal to a half. So I've got them both in terms of sixth. So then it's easier to add. So I've basically got the 3 6 from the half, and these is 2. So I'm putting that one and that one together. So all up, I've got 5 sixths. So you can see how that works pretty nicely there. So let's have a look at the question. Let's get back to our. Here's what I'm adding. Here I'm adding fractions with the same denominator. I've got 2 sevenths plus 3 sevenths. We already saw, if I've got those, let's clear these out. 2 sevenths, is it sevenths? No. 2 sevenths plus 3 sevenths, I end up with 5 sevenths. So that's easy enough. Oops. 5 out of 7. Okay, and then we had 1/3 plus a half plus a third. Now I can't add those because they're not the same type of fractions, so I'm going to use equivalent fractions to find something that both 2 and 3 will go into, and so 2 times 3 and 3 times 2. Remember there was and I've times the bottom by 3, so I times the top by 3. 1 times 3, and I times the bottom by 2, so I times the top by 2, and I get 3 on 6 plus 2 on 6, and that's like my question above, and I end up with 5 on 6. Okay, and so basically what have we done? We've seen that we've got our denominators of 2 and 3, and a number that they both go into is 6, and because 2 times 3 is 6 and 3 times 2 is 6. Okay, and you may have seen that sort of idea before, but when I've got a question like this, 1/6 and 3/4, let's have a look at that one and clear it out. So I'm going to say 1, 2, 3, 4 quarters. What did I say? I said I had 3/4, and I had 1/6. If I'm adding those, they're different sizes. So let's have a look at our lowest common multiple, a number that they will both multiply to get into. Okay, and you can see here, okay, here I've got a 1/6 and it's broken in 2, so I've got half a 1/6, I've got a 1/12 there. So 6 times 2 is 12. So there's 2 of those make up that. And for quarters, 4 times 3 gives me 12, so 3/12 fit into a quarter. So basically if I've got so that's so 3/4 is 9/12, and then I need 2 more 12ths for that 6th, and I end up with 11 out of 12. Let's see what that looks like with numbers. And so here I've left a picture there like that. So I know that 1/6, a number that both goes into that as a common multiple of 6 and 4, is 12. They both go into 12. So I'm going to have my common denominator of 12. Right? How do I get there? What do I times 6 by? 6 by 2. And because I've times 6 by 2, I've got to times the top by 2. And what do I times 4 by to get 12? I times it by 3. So if I've times the bottom by 3, I've got to times the top by 3. So I end up with 2 on 12, and 3 3s are 9 on 12, and I end up with 11 on 12. Okay, and so that's how you add numbers with different denominators. Let's go back to our success criteria. Okay, so we've done, I can find equivalent fractions. I can see the issues with fractions with different denominators. Yeah, if they haven't got the same denominator, then they're different sizes. I can use equivalent fractions to get common denominator. Yep, that's how we've done that. I can make a link between equivalent fractions and common factors. Yep, we've seen that. And I can make the link between equivalent fractions and prime factors. Okay, let's have a look at that. Last thing we're going to do, let's have a look. So I'm going to go back to large, let's go normal, and then I'm going to change this to primes. So all these are all prime factors. See, 2's a prime, 3, 5, 7, 11. Okay, let's have a look at this fraction wall. Let's look for some equivalent fractions. Can I see any lines that match up? No, there's none. There is none. Any equivalent fractions? Let's clear it. No, there's no equivalent fractions in here. So when I get down to my primes, there's no equivalent fractions. So I often will have to size them up, use equivalent fractions to do that. Anyway, I think that'll do us. Let's go back to our last one. Okay, I can make the link between equivalent fractions and prime factors. So that is when that's what I've been doing here when I've been multiplying this out. Actually, so I could have done it 1 on 6. Instead of 1 on 6 there, that is 2 times 3. This is 3 on 2 times 2. And so you can see this has got a 2 and a 3 in it. And this has got a 2 and a 2 in it. So my common denominator will have to have a 2, and a 3. A 2, and a 3. Okay, and so what did I do? For this one, I multiplied by another 2, so I've got to times the top by 2. This one, I multiplied the bottom by a 3, so I've got to times the top by 3. That was that one that was already there. So I end up, my common denominator, 2 times 2 is 4, times 3 is 12. 1 times 2 is 2, 3 times 3 is 9. 2 twelfths plus 9 twelfths is 11 twelfths. And that is the link between equivalent fractions and prime factors.